Hello everyone, today we're going to be working on example 3-7, and this example is telling us that the lamp shown weighs 78.5 newtons, and to determine the required length of cord AC so that the lamp can be suspended in the position shown, the underformed length of spring AB is 0.4 meters and the spring has a stiffness of 300 newtons over meters. So the first thing to remember is I'm just going to write out some equations that we are going to be using. So remember that force is equal to stiffness times delta. So that could be rewritten as force is equal to stiffness times length final minus length original. And this equation can be rewritten as force, sorry, force, force of AB is equal to the stiffness of AB times the deformation or delta of AB. So, in other words, it could be rewritten as force of AB is equal to the stiffness of AB times length final minus length original. And then remember that in the problem, it already gave us that the stiffness of AB is 300 newtons over meters. So we already have that information, 300 newtons over meters. So, and then we have also length original, the original length to be 0.4, was it? Yes, 0.4 meters. So the only thing that's missing from here is length final and the force of AB. So to find force of AB, what we're going to do is we're going to draw a free body diagram. So we're going to draw a free body diagram of joint A. So this joint right here. And then from there, we're going to draw reactions and forces around joint A. So we have force AB, which is the spring. From there, we have force of AC. And then from there, we have the lamp, which we know that weighs 78.5 newtons. We know that's how much it weighs. So that's weight. So the next thing that we're going to do is we're going to try to find, we're going to make sure that our y and x components are in equilibrium. So the next thing we're going to do is we're going to work with our y components. So we have the sum of our y components must equal 0. So that means that, okay, we know that f of A of C is to an angle, so we have to find its y component. And as you could see in the figure given, we know that there's an angle right here of 30. And to find the y component, that means we're trying to find this side. So if this was a triangle, we are trying to find this side of the triangle. And with correspondence to this angle, we know that it's the opposite angle of it, and we know the hypotenuse. So we're trying to find opposite. We're also trying to find hypotenuse, so that means that we could use sine since sine is opposite over hypotenuse. So we're gonna write f of a of c times sine 30. Once again, we're using sine because sine is opposite over hypotenuse. And we're doing the y components. So the other y component that we have here is the weight of the lamp, which is 78.5 newtons. So minus 78.5 newtons has to equal 0. So from there we have, if we try to solve this for the force of AC, so we have the force of AC is equal to 78.5 newtons over sine of 30. So that means that F of A of C, the force of AC, is equal to 157 newtons. So like that, we were able to verify and find the force of A of C, verifying that all of our Y components are in equilibrium. From there, what we're going to do is we're going to find F force of A of B. So the force of A of B, and the force of A of B is in X components. It's horizontal. So to find the force of A of B, we're going to try to make sure that all of our X components are in equilibrium. So the sum of all of our X components have to equal 0. So sorry. So remember that we mentioned that F of AC, force of AC is diagonal, so that means it has vertical and horizontal components. We already found the vertical component, but this also has a horizontal component. And we know that this is the horizontal component. The force is going to be acting to the left, so that's negative. So we have negative F of A of C, and since we're trying to find the horizontal component of it, so again, looking at it as if it was a triangle, this time we're trying to find the adjacent side with correspondence to this angle right here. And using hypotenuse, that gives us adjacent side and hypotenuse side. And if you guys remember, cosine is adjacent over hypotenuse. So for our x components, instead of using sine, we're going to be using cosine. So cosine of 30 degrees plus, and we don't know what f of A of B is, but we know that's positive and it's already horizontal. So we're just going to put plus F, the force of AB. And we know that also has to equal 0. But what we do know is we found the force of AC earlier on, so we could simply just plug that in. So negative 157 times cosine of 30 degrees plus the force of AB has to equal 0. So solving for F of force of AB, we get 136 newtons. So now that we were able to find the force of AC and AB, we could go back to our equation that we were talking about earlier on. So going back to this equation right here, so we're going to be using this equation, but we're going to rewrite it down here. So force of AB has to equal the stiffness of AB times the length final minus length original. And remember, we previously found the force of AB, so we could plug that in. So we have 136 newtons. We were given the stiffness in right here, the stiffness 300. So 300 newtons over meters, and length final minus, we were given length original, which was 0.4 meters. From there, what we're going to do is we're going to divide both sides by the 300 newtons over meters. We're going to divide that. So when dividing that, we get 0.453 meters is equal to length final minus 0.4 meters. And from there, what we're going to do is we're simply just going to solve for length final. So the final length comes out to being 0.853 meters. Now that we were able to find length final, with that, we are going to be able to find the length of AC. But before doing that, we now know that the length of AB right here. So we know that the total length from here to here is 2 meters. And what we just found, the 0.83 or 853, was this length right here, the length final of the spring, because this problem right here helps us with spring problems. So we knew that the length final of the spring was 0.43. Okay. So by finding this length, we're going to subtract 2 meters. We're going to subtract this to the 2 meters to give us this length right here. So okay. So we have 2 meters minus 0.853. We get 1.147 meters. So now that we know the length of this side, we're going to use that to be able to find the length of this side. Because once again, looking at it as in a triangle, we are trying to find the length or the required length of chord AC, this length. And by finding the force of AC and AB, we were then able to find the length of the spring. So what we did is we subtracted the length of the spring from the 2 meters, giving us this length. And now that we know this side, once again, if we look at this as a triangle, we know this side. So with correspondence to this angle, we know the adjacent side of the triangle, and we're trying to find the required length for this side, which is the hypotenuse side. So what we could do is we could use cosine of theta, which our theta here is the 30 degrees, because cosine is adjacent, which we found already, over hypotenuse, and that's what we're trying to find. So what we could do is we could write out cosine of 30 degrees is equal to, remember, cosine is adjacent over hypotenuse. In the adjacent side, we found out that it was 1.147 meters over, and hypotenuse side, that's the side that we're trying to find, so the length of AC. So if we solve for the length of AC, we get 1.147 meters over cosine of 30. And if we plug that into our calculator, we get that the length of AC is 1.32 meters. And just like that, we were able to find the required length of AC to be able to hold the weight of the lamp. So once again, how we solve this problem is we recall the equations that we used during when a spring comes into play. So what we did is we were we were given the stiffness of the spring and the original length of the spring. So from there, we try to find the force of the spring, or the force of AB right here. So by finding the force of AB, we would then just have to find, we were able to find the final length of the spring. And to find the force of AB, what we did is we drew a free body diagram. And from there, what we did is we made sure that our y and x components were in equilibrium. And by doing that, we were able to find the force of AC and AB. And once again, we needed the force of AB to then find the length final of the spring. So by finding the force of AB, we were able to find the final length of the spring, which was right here, which is right here. And since we were able to find the length of the spring, we were able to subtract the length of the spring from the total length of 2 meters, giving us that 1.147 meters, which was this side of the triangle. And the overall purpose of this example was to find the required length of this side. So once again, we used cosine since we had the adjacent side of that triangle, and we were trying to find the hypotenuse side. And using cosine, we were able to then find the required length of AC.